Good afternoon and welcome to the next installment of Micrographics webinars. This is Fusion 360 Design for Manufacture, a look at the design to manufacture workflow. It's presented by myself, Carl van Rooyen. I'm an application engineer with Micrographics and my email address there is carl@mgfx.co.za. Today we are going to be looking at machining from within Fusion 360, but particularly the inclusion of geometry and fixturing within the machining environment, the CAM environment inside of Fusion 360. Our agenda, we're going to start off with an intro. We're then going to look at what I call functional design. That is the actual component itself, just a quick overview of the design environment, what you can include in the design environment or workspace. Then looking at geometry for manufacturing. What geometry could you include to help the manufacturing process? Manufacturing models. We'll cover what those are, a quick look at some improvements with CAM simulation, and then we'll close off with a summary and Q&A. So onto our intro. As I mentioned, we're going to be looking at the design and manufacturing philosophies within Fusion 360. And what I mean by that is taking a look into the use of the design workspace for fixturing, how we can bring in models of your CNC table, any vices that you have, or work holding, any hold downs that you have modeled up that you need to bring into your design. And we'll see how we can do that in the design workspace and some pros and cons with regards to that. And then we'll look at the use of the manufacturing workspace where we can take advantage of the reasonably new manufacturing models option for fixturing and model adjustments or modifications. So here we're going to look at how to design up soft jaws or designing up of fixtures and defeaturing models, as well as taking an example of a model and then converting that model into a piece of stock that may be pre-cut and then loaded in for manufacturing, let's say for profiling and hole drilling. And then, as mentioned, look at some of the simulation improvements. So let's talk about functional design for a bit up front. When you have a requirement to design a component, that component is going to have to meet a specific function. It's going to do something. And so when designing in Fusion 360, we need to bear in mind the design requirement. We need to meet this functional design requirement for the component when modeling up. Now, that is something that I'm not going to cover in this webinar on showing how to kind of do that. It's really something that's difficult because it depends on the component itself. But part of the design process, part of the philosophy needs to be that we need to meet those design requirements, but we also need to be manufacturable. The component needs to be manufacturable at the end of the day. And, with the advent of 3D printing, this is becoming, let's say, a lot easier, maybe not cheap, but we are able to create more complex parts and able to 3D print them. But for the scope of this webinar, what we're going to do is we're going to take this down and look at, okay, well, what happens if we're going to actually machine this part on a CNC mill? And we're going to then look at, okay, well, we've got this part that meets the design requirements, but is it manufacturable? And part of looking at that manufacturability is cost effectiveness. The more complex the part, typically more expensive it's going to be to machine. So keeping in mind the manufacturability of the part and its design requirements, we're going to look then at machinability, and this is where I'm going to dig into a little bit here. The machinability of the component, once it's designed, Now, are you able to access all of the areas when you look at accessibility, in the model? Looking specifically at where there may be areas where there's undercuts that could require a second or a third operation or setup within the machine to be able to access those areas. We'll look at minimum radii inspections to be able to see where fillets match a certain minimum radius, or if they fall outside of a minimum and maximum range, let's say, of tools that you have available. Another inspection we'll look at very quickly is draft, just to be able to look at the components and see if where there are vertical walls, where's the draft angles above and below certain values or between certain values. And something that, there's no specific inspection tool for, but something to keep in mind is also the depth of any pockets or the depth of any cut that needs to be made. Would your tool be able to reach that? And if you need a longer tool, can you keep it rigid? Are you able to put a longer tool holder in there with the tool right at the tip of it and keep that tool rigid? The first three, the accessibility, the minimum radii, and draft, we have inspection tools available for us to be able to use and look at achieving some machinability with regards to those three factors. So to have a look at this within Fusion 360, I'm going to go ahead here to our demo component, and we're going to look at this, start off looking at this component here first, and we'll look under the inspect. And now at the moment here I'm in the design workspace, and we'll go to the inspect drop down. We've got a couple of inspection options here, and the first one I'm going to look at simply is the draft analysis, and this would allow you to choose a body that you want to analyze for draft angle, and then also select a direction. Now typically the direction here would be the Z direction for the machine. So if I pick this flat surface, it's going to give me a axis coming off normal to that surface. So let's assume that that is the Z axis of the machine. And currently I have draft angle set from -2 to +2. So the green would be the positive draft angle and the red would be going towards the negative draft angle. So if I increase these values on either side, we will see that that shading increases in its area. So we can look between the set angle to see if we have any draft angle. If we set the minimum to, let's say, 0, we'll get some gray areas, and those gray areas there are basically at that minimum draft angle. And here we can play around with the direction and see, okay, what happens if we had to place this in the machine orientated like that with the Z-axis on that flat face. And we can see here all the red is shown as basically our 0 degrees. If I change that to -2, we've got the red there, -2. We also have blue areas here now showing up. Those would be going into the negative draft angle and potentially be difficult to get to. The other inspection options we have here is the accessibility analysis. And this is a more cut and dry look at this, where we'd be able to choose the body and the direction, same as with draft, but it just shows us red and green. Green areas are accessible when machining in that direction. Red areas are just purely not accessible, so they would be your undercuts. You may need to position the part differently. So if I go ahead and change the direction here, so that we are looking at machining it sitting like this in the machine, and we can see we have green all the way around the component. And so that accessibility option will shade in the areas that are not accessible by the tool from that set direction. So we can see here, if we had to orientate this part like this, you would have issues getting to all those areas underneath. And then the last inspection option here is a minimum radius analysis. And so this allows you to put in or select the body. Just switch off the analysis here. And if we go to the minimum radius analysis, we can select the body and we can then select our maximum tool radius and minimum tool radius. So let's say we can go up to a maximum of 12, but the smallest tool that we have available is 3. It would then show us that this radius around the bottom of the part is in actual fact smaller than that 3 millimeter we see as it's gone red there. So if I change that 3 to 2, still red. And if we change that 2 down to 1, you see there now that that fillet around the bottom of that part there is bigger than a 1 millimeter radius. So we're able to go through this and find all those radii that fall within a specific range. And if I go to a more complex component here, we can do the same thing. I'm going to actually repeat the accessibility analysis. And we'll see now that I'm actually in the manufacturing workspace on this model. So the inspect tools are now limited to the accessibility and minimum radius. So if I go to accessibility, select the component, and then choose the direction in which I want to machine, assuming that this is laying flat on the bed, we can see that we have these holes around the perimeter of the part that are showing up red. They're not accessible to machine in the current Z orientation, and obviously the underside of the part. If I had to turn that direction over, we'll see once again the underside of the part. If I flip this over, we can see that we can access all of that geometry from this side. So we can see we can't get to the chamfer at the bottom there with a conventional tool. So it would give us the accessibility, back to the minimum radius, grab that one, and once again set the minimum radius tool. So let's say maybe biggest tool I have that can do a radius for me is 16 millimeters, and the smallest I have is let's say a 9, a 10. I'll pick that body, will then highlight all of the radii in red. They fall outside of that range, so I see that I will probably need to go and buy a smaller tool. So if I go down to a 8 millimeter, we'll see that the 8 millimeter cutter would be able to go into most corners, and if it was a ball nose, we'd be able to minimum radius, so that would be a 16 diameter. That would be able to go into the corners and machine all the corners around the bottoms of the pockets. We'll see now with that minimum of 8, I can't go into the holes though. So this just allows you to interrogate that model for the machinability, access on that component. So there, once again, that machinability, looking at accessibility, minimum radii, and draft angles on those components. And that helps you with the functional design of the component. Is it machinable? And is it going to be cost effective when machining? Now, like I said, this is going to be a short section because I want to concentrate more on the geometry for manufacturing, looking specifically at components and what geometry can we add to those components to help the manufacturing process. Some of this geometry that we have for manufacturing would include setup models, the actual part model itself that you want to produce. But over and above that, if you are working from a predefined stock shape that is not, let's say, generated by your setup, you may have a stock model that you want to choose. you may need fixturing for your component to hold the component in place. And then we'll look at helper geometry, what I call helper geometry. Those would be extra sketches for creating boundaries or toolpaths. And over and above that, you can also create surfaces. I call them surface extensions to help you get smoother, more predictable toolpaths. And we'll go through some examples on that. So the first portion there, the setup models, looking specifically at the part. In the image here on the right-hand side, we've got multiple parts shown in multiple setups. Now, typically the section that I'm going through would be geometry that historically would have been created in the design workspace. And we'll see in the demo that I do that doing this in the design workspace does clutter the design and adds a lot of extra bodies and components. So this is going to slowly be replaced by the manufacturing models that we'll look at towards the end of the webinar. So this may be your current way of doing things, and then we're going to look at manufacturing models, which would be an improved way. So, in the past, you may have had just a single component and for a single setup, or as the image shows here, multiple parts for multiple setups. So machining 3 top sides, then flipping that over and flipping that over, and then machining 3 bottom sides of the component. And part of the setup model would be potentially modeling in stock. So what we're looking at here, after the top side operation has been done, the component is flipped over, and the red that we see here would be the underside of the component, but the stock shown in gray would be the resulting model from the first setup. Kept it simplified, but the back side of this model, the bottom of this model, is what we would have to start machining from. So we have the through holes that are drilled, but no pockets or chamfers. And this would have been typically a secondary body within the design workspace. If you want to go further than that, you may want to include fixtures within your design, looking at adding your actual machine bed in to see how much space you have. Maybe you want to create a fixture and do mass production. You want to be able to machine 4 or 5 of these at the same time. So adding that work bed in gives you a good reference as to how much space you have. You could also add in your machine vise so that you are able to clamp those parts in. And along with that second operation, you may want to include soft jaws as well. So to have a look at how we would do this in the software, I'm going to go ahead here to this simple component. It is just a thin plate which is being machined into a curve on the top. Now I am in the design environment, and what we could do here in the design environment is go into the data panel and pull in information like a machine bed. And in this case here, what we can do is we can drag and drop those designs into the model, and that would allow for your design to be linked, that machine bed to be linked to the actual, or linked in the actual design. So we can see here that that machine bed for the Haas VF3 is linked in. So if any changes made to that bed, we are then going to see that change within this design. But now we have that surface part that I created. It's existing here as a body, and then we have the table as a component within this. So that may potentially mess around with things like bill of materials. And so we may process this further to remove this as an actual component that would show up in our bill of materials. If we wanted to go ahead and add anything else in here, let's say we've now got the table, we wanted to add any hold downs, we could open up a hold down clamp kit, copy bodies from that and paste that in here. But as we start to add more and more into this design, we would see that we are cluttering up the actual part itself, and at the end of the day it may become difficult to tell the difference between what's the actual part and what's required for manufacturing. So I mentioned in the geometry for manufacturing, adding the workbed, machine parts, and soft jaws. We can go through that process and put that in as shown. The stock itself could also be modeled up. And what we're going to do though is have a look then at the next component at that helper geometry. So, here we have that component based on the bed, but we may need to add in some helper geometry, as I call it. And one of those things would be for a component like this, where I've seen in the past is a parallel toolpath that runs from left to right as we view this component. When it gets to the end, it has a tendency to drop off the end and curve off the end. So let's see, have a look here quickly to show what that would look like. Parallel surface there. So we can look at that and we can see it tends to drop off the end there. We may want that toolpath to continue upwards. And so to do this, we would need to go and do, let's say, some surface modeling where we can create an offset from that face, so 0 degrees up, and then extend that edge outwards. And now that extended edge would give us an extended surface to work with to apply the operation to. But we can see here now that once again we're cluttering up the model. So we have that helper geometry. I've skipped a step here, but we're looking at we're looking at creating, you can create sketches. So in this example here, there is just a plain sketch underneath the component that is used to limit the position of, or to limit the area that is being machined. And if we have a look here, we have another sketch that is showing being used as a toolpath for engraving a word into the part. And then the last one here, which we're showing there with the surface, is the helper geometry to create that surface extension. And if this geometry is done within the main sort of model, it can create that clutter. So what we're going to look at next is the, in actual fact, that was the demo that I did here, the surface extension. But the next thing we're going to look at is the manufacturing model and what advantages we have when using the manufacturing model. And what we can do with this model is we are able to de-feature the design and remove information that is not required for manufacturing. And we can also use it to modify the existing design. And we can create multiple manufacturing models. So as needed, we could actually create a step-by-step process, a manufacturing model for each setup if we needed to. So the first thing we'll look at with the manufacturing model is how to actually de-feature. The list here on the left-hand side is a list of what you can de-feature from a part. We've got the options for fillet, hole, chamfer, extrude, revolve, other, and then there's a manual select as well. And you can also adjust by size. So the image on the right-hand side there shows the selection of the body. There's no manual feature selected, but the feature size slider allows you to slide back and forth to basically choose features by their size. So that image there shows fillets, holes, and chamfers that are being selected to defeature by their set size. The manufacturing model can also be used to modify the existing design. So it can be used to add or remove solids and surfaces. Once again, that image on the right-hand side there shows the previous part where all the pockets have been removed from that. You can modify by creating sketches, extruding, revolving, etc. All the standard modeling processes. And then this can also be used to model fixturing like soft jaws or fixture plates. In the example we see in the image on the right at the bottom, we've got some soft jaws there modeled up for that red component, and the image on the far right hand side actually shows the piece of plate which may have been laser cut and then mounted to be mounted with cap screws onto the bed to then be cut and profiled and holes drilled. So we'll move on to a demo for the manufacturing models, and the first demo we're going to look at is that helper geometry. So if I take this component back to the design environment, it's very similar to the previous part we looked at. However, in the design environment, we'll see that under bodies, we only have the one body, and under sketches, we have a few sketches that we use to create the component. Now, this component in the design environment is simple. That is the part that we need. But if we go to the manufacturing environment, we're able to go to setup and create manufacturing models. Now this one has those manufacturing models predefined, so I can go in here, expand out manufacturing models, and then choose one of the three models to look at. So if we go to the without surface manufacturing model and enable that, we're able to right click and edit, or double click on that to edit that model. And within this model, we can expand out the tree, and we can see that we have, various different, let's say, basically the same body, but we have, where is it? There we go. We have sketches here to give us that text geometry. Now back to the design environment, if we looked at the sketches here, we will see that there are no sketches here for that text. So that is added in the manufacturing environment. If we go to the with surface manufacturing model, we'll see that this one includes a surface that has been created over the face of the part. And if we go to with surface 2, this one has a surface that is just across the curve. And so these are used to help in machining process. So if we go here and look at what a parallel toolpath would look like over this hole, without that surface, it will tend to dip into the hole and then not machine across it. And we may want to come in later with a different toolpath and finish off that fillet around that corner. Maybe go with the flow toolpath and go in there and do the fillet with a flow toolpath. So we want that parallel toolpath to skip straight over the top of the hole. In this case, I have tried the contact only. You can see it's actually enabled. If we disable that and recalculate the toolpath, it will still dip down into that hole. Let's let it change. to that toolpath. So what we can do is we can create that surface in the manufacturing model and generate the same toolpath, but on the surface rather than on the actual part itself. And so we'll see here that it machines straight over the top, and you have less linking moves and less retracts on the toolpath. So much smoother toolpath there. However, if we look at where the parallel toolpath climbs the wall, we have quite a big step here, and it leaves us with some large cusps on the part. So we could use, let's go to the third setup here. We could use that surface, and in fact I have a combination here of using that surface just in the corner to machine on that surface, so the surface over here, as well as using the sketch to limit where I am actually machining. So if we go to that corner only toolpath and edit, you see that the geometry is, the machining boundary is the sketch, and the actual avoid, I've used the avoid touch surface option, and for avoid touch surface I have selected the surface body that represents that curve in the corner, and that calculates out the toolpath to machine that corner using a vertical, or basically using a parallel toolpath along the length of the part. So here we have a few different cases of being able to create manufacturing models with that so-called helper geometry within the manufacturing model. And you'll see for each of these setups, if I enable the setup, that manufacturing model with that geometry is enabled per setup. This is a process that I'll go through in a following demo. So once again, looking at that manufacturing model, the next demo that I need to do is actually to go back into that plate and demo how to defeature that plate. So let's have a look here quickly. Yep. So let's go back to the plate over here. And so if I need to create a manufacturing model from this, I'll go to the Manufacturing Models tab or up to Setup and choose the Create Manufacturing Models option. That will create a manufacturing model, and you can then give that a name. So I'm going to call this Profile Bank. And once again, double clicking on that will edit that profile. There's various things you can do. I'm going to go ahead here and choose the Remove Features option, and I want to go ahead and remove fillets and chamfers from the selected body. I'll pick the body, and it will then highlight all those components or all those features to remove. And so we can see there's various fillets and chamfers. If we use the slider, we'll see how those features slowly removed from that component by their size. So what I'm going to do here is remove all the small fillets and chamfers. I'm happy with that. We'll click the delete option at the bottom here. Have a look. Yeah, go ahead and delete that. That will process and that will remove those highlighted fillets and chamfers. What you can also do once that is done, you can also choose features manually. So there's a manual selection option here that you can pick to manually select various features to remove. Now, this is taking a little bit of time. There we go. Okay, so the working is done, and all of those chamfers and fillets that were within that size have been removed. So if you want to manually remove features, you're able to select manual features, pick the components that you want to manually remove. In this case, I'm choosing the walls of the pockets, and that will go ahead and remove those pockets. Once again, I'll hit delete, and that will work at deleting those pockets. Now for this component, I'm not going to go ahead and defeature it completely. What I want to do is assume that this part is laser cut from a blank piece of aluminium and then profiled. So we can also use things, your standard modeling options. So I'm going to create sketch. On the underside of the part, project that geometry in, and also just going to delete all the unnecessary parts in the center here. That will just help me with creating an extrusion. Sketch, and I'm going to create an extrusion of this component through the thickness and join it in. It's a very quick way of closing off all of the holes, and from here use the press pull option to now resize this. Do that by dragging a box through it, and this will allow me to offset this outwards by an extra, let's say, 4 millimeters, and that would be the aluminium blank that is cut, to be laser cut. So I can finish edit on the manufacturing model, and there's my profile blank. So for setups, I could go ahead and create a new setup for that profile blank and choose the cutting method. And from here, I can go and assign various, I could go through the standard process of creating stock, creating my work coordinate system, and actually using that now to create the laser cut, to cut that profile for the part. If we go back to the design environment, we have the original part there in the design environment. So at any point, we can create a new design, a new manufacturing model, and activate and change between those manufacturing models for the various setups. So that is this component, looking at just a simple blank part. What I'd like to do is go through the process of from start to scratch on this component here, looking at two different setups. I'm just looking at the time, I've got about 20 minutes left. See if I can quickly squeeze this in. So in the design environment, we have our setup for our components. Go to manufacture. There's no manufacturing model here, so I will create a manufacturing model. And one thing that we haven't looked at yet, and this example will show quite nicely, is how to edit that manufacturing model and actually bring in something like a fixture or a vise. So here I have a vise that I would like to use to clamp this component down. But if we go from the design panel and try and drag and drop that in, we will get a warning here that says insertion of components into manufacturing model is not supported yet. So we can't add that in directly from the data panel. But what we can do is we can go to insert and we can insert derive. We could also insert from the master car. So that's how I got the cap screws into the previous models, was to insert from the master car component. So I'll go insert derive, and from the insert derive, I'm able to pick the vise. So I need to go down and find it. So there it is. Select the vise, and that will then basically open up that vase and allow you to choose the components from that vase to bring into the into the manufacturing model. I'm going to go ahead and select the 3 sub-assemblies for that vase and hit OK. That will then import that vase as a derived component into your manufacturing model. Now, this is a vase that shouldn't change, so you can feel free to break that link to that vase so that that derived link is not there. So I've broken that link and the vase is brought into the manufacturing model. For now, I'm going to switch the visibility off on that vase. What I'd like to do is create the stock that I'll use to machine this part. Once I've created the stock, you can then use joint to connect the stock to the vase. So quickly go through this to create the stock. It's about 120. I'm going to extrude that up by 18. And this is actually going to be two-sided, so we'll go -18 in the one direction, and the side 2 is going to be 6. And I'm going to create this as a new component to make it a little bit easier for me to actually just make my life easier here. 6, 18, and that's going to be a new component. Just makes the life a little bit easier when selecting that during the setup process. So we now have a new component, which is going to be the stock. I like to set the opacity of this down a little bit so we can still see the part within it. And so we can see there is our stock sitting around the component, and we can switch the vase on. Now with this vase, if we grab a component and move it, that whole thing moves on its own, so as a separate entity. So the first thing to do here is I'm going to grab let's have a look here, we'll go grab components, and I'm going to grab that front jaw and move it to the stock width. Once I grab that front jaw and moved it to the stock width, I'm going to create a rigid group from that. Those 3 items will capture that position. And now this enables me to go ahead and join that jaw onto my component. And we do need to move that jaw down so that we can clear the vase with the machining operations. And so that now puts the stock in the drawer. If I really wanted to, I could put parallels in there so I know the exact dimensions. I can still move this drawer as required, move that joint to position it, but I'm going to leave it there for now. So that would be my first manufacturing model that represents the component, the fixture, the stock. Finish edit there. And for manufacturing model 1, I'm going to go ahead here and call this setup 1. Now, I already have some machining setups here in the part, so all the different operations. But for setup 1, go into that setup 1 and edit the setup. We now have options here under model to choose the manufacturing model. Now, default would be the entire part, it would be the entire model. I want to go to the setup 1 manufacturing model. And here we need to choose what the actual model is. So I'll click there by model, go to the manufacturing model, and I'm going to pick my part in the list there. enable fixtures, and then for fixtures, just to make life easier here as well, go ahead and pick in that browser on the left the 3 components that make up the fixture. And on the stock tab, I'm going to choose the stock from solid and pick the stock that was modeled in. Hit OK, and that will then set up the, or that will then change that setup to include all of that data. And now I think I messed that up and did that on setup 2. Okay, let me just run through that process again quickly. The model from manufacturing 1 setup is that one there. Fixture are those 3 there. And the stock from solid is that one there. Just double check setup 2 here. Okay, not sure what happened there, second time lucky. So now if you see I change to setup 2, all of that information disappears. Changing to setup 1 enables the corresponding manufacturing model. And they don't have to have the same name, so I could say top side ops. And if I activate setup 2 and then go back to setup 1, it activates that linked operation. So that would be the setup for the top side. Now if I want to do for the bottom side, take that manufacturing models, create a new one, and what I actually want to do here is duplicate the existing one because that already has all the VICE information in the stock. So I'm going to go ahead there and duplicate and take that top side ops, make that bottom side ops. And edit that one. So quickly to start off here, I'm going to hide the jaws, that component which was the stock. I should have renamed that to stock to make it more obvious. That component now needs to be modified. So we can go down to the history here and modify that in history. So I'm going to go ahead here with a one-sided operation, bring down the 6 millimeters. That represents the bottom portion of the stock that I'd be left with. And what I'm going to do here as well is take the body from the setup bodies, copy that and paste it into the stock. And that will then allow me to combine those 2 bodies together to create stock for my second operation. So let's have a look. But before I do that, I do want to defeature the body that we have here. So I'm going to go ahead here and choose the defeature option. Let's just first set the opacity. I'm going to go ahead and remove features, and because this is my stock, I'm going to represent my stock. I do not want to have the pocket and the 2 holes because those would not have been machined yet, as well as the chamfers. So I'm going to go ahead and just allow it to remove the chamfers. We can see them highlighted in different colors. Those features. There we go. Okay, that looks a lot better. So I can now take those 2 components and combine them. And that creates my stock. Okay, so set up 2, sorry, set it all the way out. And I would then need to reorientate the VICE to the opposite side as well. See, I'm running late on time here, so what I'm going to do is I'm going to go ahead and go to the completed setup. This may run a bit short. And here for the completed setup, go to Setup 1 and view the setup and toolpaths. And while we're here, I'm going to just talk quickly about the simulation improvements, where you're able to either hover over an operation and see its toolpath, or you can select the operation and it will then display the in-process stock simulation. So you can actually see by clicking on the part or on the operation the resulting stock removal. And so here we have our setup 1. And we look at the manufacturing model. Setup 1 is active. If I go to setup 2 and activate setup 2, it is turned over, and we can then view the operations for setup 2. We've got the facing to remove stock, excess stock that was clamped. This has soft jaws modeled in as well, and that's in the manufacturing model. We've got the pockets drilled in on the reverse side, finished, and then as well as spot drilling. So we have those two different manufacturing models linked to the two different setups. And just to close off with that last slide and then a quick summary, the improvements in CAM simulation, you now got that option of having that in-process stock generation. So when you click on a toolpath, it will show you what the stock would look like when that toolpath is completed. So it shows you all the previous toolpaths, stock removal, as well as the selected stock. The nice thing about this is that you can jump in at any point, and let's say go here to the pocket mill and simulate, and it will simulate all the removal up to that point, and then only simulate your actual required simulate and show you the removed material. I'm not quite sure why. Okay, this one's not showing 100% now today. Let's go back to this one. Let's say we want to go and view from the outside contour. So it will take into account all of the removal up to that point as well. And then it will go through and machine. Okay, so in summary, what manufacturing models allows you to do is it allows the designers to concentrate on the functional design, and it reduces their need to modify the final model, final design to aid the manufacturing process. And the manufacturing models gives you more flexibility to create those models, to isolate fixtures from the design, and allow for multiple stages of machining to be represented in those machining manufacturing models. And then just to jump on that last point of the simulation, there's the update to the stock previews allows for a better simulation experience. Being able to select a component and view the stock that is removed up to that point, including that operation, is very nice, and being able to start a simulation halfway through and have that stock removed is a very nice option. So that is a quick summary, reaching towards the end of the hour for the presentation. I'll open up for any questions. There is the chat panel available to ask any questions, and we can answer those questions. Okay, I haven't seen any questions come through, so thank you for attending the webinar hosted by Micrographics. We have offices in Johannesburg, Cape Town, Port Elizabeth, and Durban. So if you have any questions regarding anything in the webinar, you can feel free to contact those offices, and the webinar will also be uploaded onto YouTube, onto our channel on YouTube, to be able to watch at a later stage. Thank you for attending the webinar, and have a good day.